Okay, strap in, everybody. We're going deep on LLMs this time.
Large language models.
Yeah, you got it. We've
Yeah.
got this research paper you sent in,
Right.
all about a new technique,
Sparse attention.
sparse attention.
Yeah.
Right. We're going to break it all down for you. The paper is called Native Sparse Attention, Hardware-Aligned and Natively Trainable Sparse Attention.
Quite a mouthful,
Yeah, it is. It's a long one.
but a good one.
So let's jump right in. You know when an LLM uses full attention?
It's kind of like if you were
Yeah.
trying to read like a whole encyclopedia just to answer one simple question.
That's a lot of pages to turn.
It's not exactly efficient.
Yeah, no kidding. So that's where sparse attention comes in, right?
Right.
It's a way to be more focused.
Much more. It's like having a research assistant,
Yeah.
someone who knows exactly where to look for the info you need.
That's awesome.
Yeah.
Okay, I'm hooked. So how does this sparse attention actually work?
Well, okay, first we got to talk about like why we even need it in the first place.
Okay.
LLMs are amazing, right? Yeah.
But they are so computationally expensive to train and run,
Especially when you're
especially when you're working with these long pieces of text.
right.
And
Tons of data.
yeah, and a big chunk of that cost, it could be like up to 80% in some cases,
80%.
comes from this thing called the attention mechanism.
The attention mechanism. Okay, so what is that exactly?
So attention is basically how the LLM
Okay.
figures out which words in a sentence or a paragraph are like
Oh, okay.
the most important ones.
I see. So it's like
Yeah, it's
it's
like
prioritizing its reading.
exactly. It's like figuring out what to read first
Okay.
instead of just like,
Right.
reading everything.
Skimming through headlines.
Yeah, exactly.
Yeah.
But it's doing that with like, thousands or even millions of words,
Oh, wow.
trying to figure out which ones are the most relevant to whatever it's doing.
Yeah. That sounds like a pretty,
That's a lot of computation.
computationally heavy.
So sparse attention is like a way to,
It's a way to make that whole process more efficient.
okay, more efficient.
Yeah.
Gotcha. So
Yeah.
haven't people been trying to
Oh, people have, yeah.
figure out sparse attention?
They've been trying to do it, but as this paper points out, a
Right.
lot of the methods
Yeah,
haven't really worked as well as they...
as people hoped.
Yeah.
Okay.
Like some say they're faster, but then when you try to use them,
Uh-huh.
those speed gains don't always like actually happen in real world situations.
Yeah.
And a lot of them just, they aren't compatible with the architectures that
Right.
we use in the really powerful LLMs.
Oh, so it's like,
It's like having a fancy new engine that doesn't fit in your car.
yeah, that's not helpful.
Yeah, it's not very helpful.
Right.
And then there's another issue. So a lot of the current methods, they try to make the attention sparse.
Uh-huh.
After the LLM's already been trained,
Right.
this paper says we need to have something called natively trainable. Sparse attention.
So it's built right in
Meaning it's like,
from the ground up.
it's there from the start. Yeah.
So it's like
the big
teaching
teaching.
a student
Yeah.
good study habits
Exactly.
from the beginning.
Rather than trying to like
Yeah,
cram everything in at the last minute.
exactly.
So that's where this paper's contribution comes in.
Okay.
They introduced this new approach called natively trainable sparse attention,
Natively trainable sparse attention.
or NSA for short.
NSA. Got it. Okay, so what makes NSA so special?
It uses this really clever hierarchical approach.
Oh, okay.
Imagine you're trying to understand
Right.
like a big legal document.
Sure.
You wouldn't just like start reading word for word from the beginning.
No.
Right? You would probably like skim the section headings.
Right, get the
Get
gist.
the gist.
Big picture.
Exactly. Then you might focus on like the key paragraphs in each section, and then finally zero in on like the specific sentences or phrases that are really relevant.
So it's kind of breaking it down.
Yeah, NSA works in a similar way. It
Yeah.
lets the LLM process information
Okay.
at different levels of detail.
I see. That's cool. So it's like,
Yeah, it's like having a team of experts,
okay.
each one focusing on a different aspect.
Right.
So NSA actually uses 3 different attention paths.
Oh, 3.
Yeah, compressed attention, which is like getting that gist.
Big picture.
Yeah, selected attention, which zeroes in on specific key elements.
Okay.
And then sliding window attention, which keeps track of like
Okay.
the most recent information.
Got it. That's neat.
Yeah.
So what is it about NSA that makes it so special?
Well, this paper says that one of the things that makes it really special
Yeah.
is that it's what they call hardware aligned.
Hardware aligned. What's that?
It basically means that it's optimized to run on
Uh-huh.
the kinds of hardware that we use for LLMs,
Oh, okay.
like GPUs.
I see.
This is really important because a lot of times
Okay.
you can have these theoretical speed ups, but they don't actually translate into real world performance gains.
unless the software is designed for the hardware.
Exactly.
Right.
It's like having a race car with a really powerful engine,
Right.
but terrible tires.
It's not going to do you any good.
You're not going to go very fast.
Exactly. Okay.
But NSA is designed to really make the most of the hardware it runs on.
So you get those speed gains. You actually get the benefits.
That's awesome.
Yeah.
Okay, but
Yeah.
the real question is,
Does it actually work?
does it actually work? Yeah,
Right.
it
What
works.
were the results are pretty impressive.
Really?
Yeah, even on tasks where it doesn't have this huge speed advantage,
Okay.
because maybe the text isn't that long,
Right.
NSA still performs as well, or even better than full attention models.
Oh, wow.
But where it really shines is on tasks
Okay.
that involve these really long sequences of text.
Oh, that's where
Yeah, that's where things get
that
interesting.
is really interesting.
So they tested it on this thing called the long bench benchmark. The long bench benchmark.
yeah, which is designed to see how well LLMs can handle these long, really long pieces of text.
Yeah.
And NSA outperformed other sparse attention methods,
Oh, wow.
and it even beat the full attention model.
So it's faster and it's better?
It even aced this test,
Wow.
called the needle in a haystack test,
Needle in a haystack. What's that?
which shows that it can find like really crucial information buried in
Wow.
huge amounts of text.
So it's faster, it's more accurate
Yeah, it seems to be.
when it's dealing with these long texts.
Yeah.
That's amazing. What about reasoning through complex problems?
That's where the chain of thought reasoning comes in. Okay,
Okay.
they did this experiment where they used NSA to train an LLM on a bunch of like
Yeah.
really complex mathematical reasoning tasks.
Okay.
And it significantly outperformed a full attention model.
Hold on. So you're saying that...
It suggests that NSA doesn't just make LLMs faster,
Yeah.
it might actually make them smarter.
Smarter. Whoa,
Yeah. It's a bold claim,
that is bold.
but the results are really interesting.
That's super interesting. And so this is just the beginning
Yeah, this is really just the beginning.
of what NSA can do.
What NSA unlocks for these specialized LLMs is where things get really mind-blowing.
Okay, I'm definitely intrigued. I want to hear more about that. Let's save that for part 2, though.
Sounds good. Remember those 3 attention paths?
Oh, yeah.
Compressed, selected, and sliding window?
Right.
Well, what's really interesting is that each of those paths,
Yeah.
it seems like they each develop their own kind of specialty during training.
Oh, really?
Like they each become an expert.
So it's like a team
Yeah, like a team of experts.
of experts inside the LLM.
Yeah.
That's kind of cool. So tell me about these specialists.
So the compressed attention path,
Okay.
that one seems to get really good at understanding, like, the big picture.
Okay, so that's the one that's kind of like...
Yeah, it's like skimming the headlines.
It's like having an executive...
Who can, like, quickly summarize a ton of information
Right.
and pull out the key takeaways.
That would be amazing.
Right.
For
Yeah, like if you were
like a legal case
trying to make sense of a complicated legal case
or a dense scientific report.
or some dense scientific report,
Yeah.
you wouldn't have to spend hours
Yeah.
just trying to figure out
Just to get the gist.
what it's even about.
Yeah, that would be a lifesaver.
Yeah.
Okay, so what about the selected attention path?
So that one is like
What's that one's specialty?
it's like a laser-focused analyst.
Oh, okay.
It zeroes in on like the most crucial
Okay.
bits of information.
For the specific facts.
Really important stuff.
Yeah, the data
Yeah.
points, the arguments
Yeah.
that are essential to understanding
That's evident.
whatever it is you're looking at.
Yeah.
So like imagine
Okay.
being able to instantly pinpoint
Okay.
the most relevant clauses in a contract
Oh, that would be huge.
or the most compelling evidence
In a research paper.
in a research paper. Yeah, that's awesome. So we got the big picture strategist.
Right.
We got the detail-oriented analyst.
And then you have what about sliding window?
The sliding window is like the memory keeper.
Right.
It makes sure that the LLM doesn't lose track
Oh, okay.
of like the immediate context.
So it's kind of like
It's like a short-term memory.
yeah.
It remembers the most recent events or pieces of information.
Okay.
This is really crucial for things like,
So like conversation.
yeah, conversation,
Storytelling.
storytelling.
Where you really need to understand
You got to remember what just happened.
the flow of things.
Yeah.
Okay, so it's like a note taker
Yeah.
that never forgets a detail.
Exactly.
That's pretty sweet. But why is this specialization?
Specialization could be like the key
Oh,
to developing LLMs that are not just generally intelligent,
right.
but are like experts
Oh, wow.
in specific domains.
Okay, so you're saying,
Instead of just having a general LLM,
Yeah.
we could have,
yeah, you could have an LLM that's like a legal whiz
oh, wow.
that can analyze contracts, draft legal documents.
And even predict case outcomes.
Yeah, even predict case outcomes.
That would change everything.
Yeah, that would be a game changer.
What about one that's like
Or what about one that's like a medical expert
a medical expert
that could diagnose diseases, recommend treatments?
and help with drug discovery?
Yeah.
That would be huge.
The possibilities are really mind-boggling.
Yeah, they are. It's not just about professional fields, though, right?
Oh,
Like, imagine an LLM that's like a master chef.
yeah, that could generate recipes based on like your dietary needs.
Yeah, like allergies.
And what you like.
Exactly. Or one that's a personal stylist,
Oh, yeah.
giving you fashion advice.
Based on your style
Yeah.
and your body type.
Now you're just making me hungry and want to revamp my wardrobe.
Seriously.
But seriously, though.
how realistic is all this?
Yeah, is this specialized LLM future really coming?
Well, it's still early days.
Right.
But the fact that NSA, these different attention paths are showing this kind of specialization,
Right.
it's really promising.
Yeah.
It suggests that we're on the right track
Okay.
to understanding how LLMs learn
So it's like
and how we can guide them to develop these highly specialized skills.
we're not just building tools. We're
Yeah.
like
Yeah, it's like
nurturing young minds,
Well, nurturing young minds.
guiding them to reach their full potential.
Yeah.
But with great power comes great responsibility, right?
Absolutely.
Are there any potential risks
Oh, yeah.
or ethical concerns that
Definitely.
we need to consider as these?
As these specialized LLMs get more sophisticated,
Yeah, because things could go wrong.
things could definitely go wrong.
Yeah, it is exciting to think about all the good that could come from these specialized LLMs.
It is. But we also need to be careful, right?
Yeah, we can't just get caught up in all the hype and
And ignore the risks.
ignore the risks. Yeah.
We need to be having these conversations now
Right.
about the potential downsides.
Yeah. And not just the researchers.
Right? It can't just be us.
And developers.
Yeah, we need policymakers, ethicists,
So public.
everyone needs to be involved.
Yeah.
Because ultimately it's not just about the technology itself.
Right. It's how we use it.
It's about how we use it and
What kind of future
what kind of future we want to create.
that we build.
Exactly.
And that's where you come in, listener.
Yeah.
Because, understanding this technology
So it's the first step
is the first step to being able to shape it.
to shaping its role in our lives.
So as we wrap up this deep dive,
Yeah.
we want to leave you with some food for thought.
Okay.
Imagine a world where anyone can access
Yeah.
the knowledge
The expertise.
of these specialized LLMs.
What would you do?
What opportunities?
The opportunities would that open up?
What challenges do you see?
Yeah. Are there any potential problems?
Because these aren't just theoretical questions.
No.
They're questions that are going to shape
The future we all share.
the future we all share.
So
So stay curious, stay informed,
stay engaged.
and stay engaged in this conversation.
Because the future of AI is
Yeah.
being written right now.
And we all
We all have a role to play.